You are here now, this is our present. The invention of the internet was, almost 30 years ago, like the fall of the Western Roman Empire. That's 45 times further back in time, and those Romans are closer to us than the construction of the Great Pyramids of the Second Summer. And those monuments themselves are 3 times closer to our present than the paintings in the Lascaux cave. As for the mastery of fire by the first humans, that's 30 times further back in time. And those first flames themselves are 150 times closer to us than to the extinction of the tombs. That's right. In short, when we look at the dizzying spans of time that came before us, we quickly find ourselves dealing with thousands, millions, even billions of years that are extremely hard to imagine and that almost inevitably slip through our fingers. Fortunately, there's a clever way to make the immensity of these time spans more concrete. To do this, you just have to condense all the time that has passed since our universe began into a single one of our years. By compressing the 13.8 billion years of our universe's history into just one of our years, we get a calendar where each month contains 1.15 billion years each day, 37.8 million years each hour, 1.6 million years each minute, 26 millennia, and each second, 438 years. From then on, it becomes possible, using this cosmic calendar, which begins on the first day of the year with the birth of the universe, and ends on December 31st in the evening at midnight. That's where our present is. To put into perspective monstrous spans of time, and to make tangible the staggering temporal distances that separate us from events that took place in a past extremely distant from us. In time, fasten your seatbelt. You are about to fly over 13.8 billion years of our universe's history in just a few minutes of your life. The story begins on January 1st at midnight, and the universe that has just begun looks absolutely nothing like the one we know today. Because at that time, it contains neither stars nor galaxies, and even though it is billions of degrees hot, there is nothing to see. Because the universe is so hot and dense that light can't even travel through it. And then suddenly, when the universe is 15 minutes old everywhere at the same time, it almost instantly goes from opaque to transparent, producing a flash of considerable intensity, before plunging back into darkness the very next fraction of a second. In this still starless cosmos, darkness will reign for nearly a week, during which, in total darkness, very slight density fluctuations force the evenly scattered matter to begin structuring itself. Slowly, filaments millions of light years long gather together and begin to outline the beginnings of an immense cosmic web. And it is inside these first cosmic structures that, under the effect of gravity, around January 6th, immense clouds of gas begin to collapse in on themselves. By compressing matter to the point of heating it to tens of millions of degrees, they ignite the very first stars of the universe, bringing it out of darkness. These stars, which bring an end to the darkness of time, are so massive that they burn out quickly and exist for only a few hours, at most, before dying in gigantic bursts of matter and radiation. And insane amounts of time keep passing, 100 million years later in reality, which is barely 3 days on our calendar scale. In the densest regions of the cosmic filaments, the very first galaxies of the universe begin to form. None of them have majestic spiral arms yet. All of them are irregular in shape and violently turbulent. 2 weeks later, a gigantic gathering of matter containing enough gas and dust to ignite several 100 billion stars begins to take shape. By giving birth to an embryo several 100,000 light years across, like the billions of others that already exist throughout the universe, but this one is special. It will later become our galaxy, the Milky Way, and time keeps moving forward throughout the month of February. All over the universe, new galaxies are born and set off in their wake in a strange cosmic dance that has never really stopped since. Over the coming weeks, as they attract each other, they will group together and form galactic clusters, colossal structures that can contain tens of thousands of galaxies. Within these clusters, the galaxies, engaged in gravitational war games, brush past each other, collide, and sometimes even crash into one another at millions of kilometers per hour. trapped in one of these immense gatherings. Ours, which keeps absorbing smaller ones, is still in a phase of growth. Within these gigantic clouds of gas, waves of star formation are triggered at a frantic pace, while at its center, a quasar regularly lights up for a few hours on the calendar. Because the supermassive black holes that sit at the center of almost every galaxy in the universe regularly swallow up large amounts of gas, and sometimes even entire stars during these turbulent weeks. In the process, they give rise to their own displays of matter, brighter than the billions of stars in their own galaxies combined. About a month later, the hyperactive centers of the galaxies begin to stabilize, and some of them now have organized shapes. Two major families of galaxies are being shaped by past collisions. The elliptical ones, older and more massive, where star formation gradually comes to a halt. And the spirals, such as the Milky Way, which have been relatively spared from large-scale collisions. And the universe continues to evolve, with billions of years, in reality, passing by on the scale of the cosmic calendar. It will take another 2 months for, in our galaxy, the swirling clouds of gas that intertwine and influence each other to finally take the shape of a disk with spiral arms. Inside these fertile regions, which are real stellar factories, billions of new stars are ignited. These are added to the even more numerous ones that already make up our Milky Way, among which none is our Sun. Monstrous spans of time will pass in reality. 3.5 months on the calendar scale, during which, everywhere in the universe, just like in our galaxy, stars are born, live, and sometimes die. Nebulae are torn apart. Clouds of interstellar gas collapse in on themselves. And then, on August 31st, in the second spiral arm of a galaxy, like so many others, but the most extraordinary one, because it's ours, a huge cloud of molecular gas and dust, scattered over a volume several light years in diameter, begins to contract under its own weight. This has already happened billions of times, and it will happen again. But this cloud is special, because it is the one that will ignite our Sun. As it collapses in on itself, the layers of gas begin to spin, and in just a few hours, about 5 million years in reality, under the combined effect of gravity and rotation, a small part of the cloud of gas and dust spreads out, and it takes the shape of a turbulent disk within which, in just a few minutes on this timeline, that is, a few millennia. In reality, through collisions, blocks several kilometers wide are formed. These are the starting points of the worlds to come. While most of the matter plunges and accumulates at the center, where an ordinary star begins to ignite. In total, just over a day, on the scale of the calendar, was needed for 99.9% of the matter from the initial cloud to end up in the star. And in the early morning of September 1st, the king sits at the center of the system that bears his name. The Sun, around which planets still in their growth phase revolve on trajectories that are still unstable and imperfectly cleared. A few dozen hours later, the system has stabilized. One of the rocky worlds that has just recently been born will soon become our planet. Let's pause for a second on this idea. When the Earth appears, 2/3 of the age of the universe have already passed, and our dear blue planet is then a red world. A blazing hell, covered in molten rocks and continuously hammered by meteor showers. The impacts enrich the Earth with heavy metals that sink to the center of the planet to form a core, a metallic nucleus that will become the engine of the Earth's magnetic field, which still protects us today from solar radiation. On the evening of September 3rd, just 3 days after the solar system was formed, the primitive Earth was violently struck by a protoplanet the size of Mars. Under the force of the impact, thousands of cubic kilometers of rock and metal were instantly vaporized and thrown into space, where they formed a vast ring of molten debris that within minutes on the cosmic calendar would clump together to form the Moon. The surface of the Earth, like that of our newborn satellite, was then covered by a vast and unique ocean of boiling magma, several hundred kilometers deep. And because of the heat accumulated from the violence of the impact, it would remain in place for nearly 3 days until September 6th. The surface has now cooled enough to solidify, and a crust of rock is beginning to form. Continually pierced by intense volcanic activity, fissures several hundred kilometers long are regularly opened all over the eastern part of the planet. It is through these weak points that the excess energy released by radioactive materials heating the Earth from within escapes in the form of lava. A few days later, the degassing of magma oceans and the ongoing eruptions began to give the planet an atmosphere rich in methane, carbon dioxide, sulfur hydroxide, and water vapor. Under the dark and opaque veil of a sky smothered by ash and dust, the surface has now cooled enough for water to remain in a liquid state. And so the very first oceans begin to form. These are still shallow, and their temperature is right at the boiling point. One orbit around the Sun later, in reality, just 3 days on our calendar, an intense barrage begins, the Late Heavy Bombardment. For about a week, around 10 comets or asteroids larger than a kilometer hit the Earth every second on the calendar. This heavy fire from the sky brings desolation to Earth, but it also carries a treasure in the form of ice. Water is trapped in large quantities in these rocks from the sky, and the steady rain will gradually raise the global level of all the oceans around September 20th in the primitive oceans, bubbling with chemical activity. Under the effect of unleashed lightning, simple molecules such as amino acids, lipids, and nitrogenous bases begin to assemble. Until then, we will probably never know exactly where or how. In this immense pressure cooker, still subjected to a steady bombardment of meteorites, pieces of the puzzle fit together. And that a tiny bag of chemicals, a sort of chaos in dynamic balance, starts to hiccup. For all life on Earth, September 20th is an anniversary. In fact, in geological formations dating from that time, we find traces of the activity of unicellular organisms feeding on ferrous ions, from which they draw their energy. These microscopic little bubbles may seem to be nothing more than insignificant cells without head or tail. They are nevertheless the first living beings to have inhabited our planet. 2 days later, the Earth's crust begins to fracture into several pieces, which start to move under the effect of convection currents inside our planet. This is the birth of the first continents. At the very end of the month, colonies of cyanobacteria can now be found on the shores of the primitive oceans. These organisms have developed a revolutionary ability to use sunlight to produce energy. This is called photosynthesis, and some of these tiny cells even release oxygen, a molecule that, until now, was almost absent from planet Earth. It continues to orbit its star, which moves through space, making a complete revolution around the center of the Milky Way. In just under a week on the calendar, the Sun has just completed its 5th revolution, 2 full orbits around the center of the Milky Way. Later, in mid-October, the oxygen produced by the activity of these photosynthetic microorganisms begins to have an impact on the entire planet. By combining with the dissolved iron in the oceans, the oxygen causes it to precipitate, and over the next 2 weeks, time keeps passing, and the oceans continue to rust, changing from a light green color, characteristic of an iron-rich and reducing environment, to shades of red and orange. And when all the iron is deposited at the bottom of the seas, and the oceans begin to trade their orange hues for the blue we know today, the great oxidation begins in all the oceans of the world. The massive arrival of oxygen in the water is a real catastrophe for most organisms. In the days on the calendar that follow, living beings capable of breathing, of using oxygen to produce energy, will gradually take over those practicing fermentation. And countless species unable to cope with the arrival of this new poison will disappear. Sometimes evolution is a revolution without looking like one. On the surface, oxygen destroys the methane present in the atmosphere, and the gradual disappearance of this powerful greenhouse gas will trigger, starting the very next day, a colossal ice age that, for nearly 10 days, will cause the average global temperature to drop to around -25 degrees C. Everywhere on the surface, the Earth is completely frozen, sheltered under a thick layer of ice. Life, however, continues to evolve when, on November 5th, intense volcanic eruptions free the Earth from the grip of the ice. The first complex cells, equipped with a nucleus and internal organelles, appear. These new, much more sophisticated cells, called eukaryotes, are the ancestors of all complex forms of life. All fungi, all plants, and all animals are descended from them. Another day has passed. Nearly 40 million years in reality, and in the oceans teeming with microscopic life. Now there are living beings visible to the naked eye, and they are more than the sum of their parts. Before November 6, all living beings were almost exclusively bacteria, invisible to the naked eye, drifting in the current or gathering in colonies. But now, some complex cells are coming together to form the very first multicellular organisms, made up of cells that organize themselves as a team and divide up the tasks. Some take care of capturing food and digestion, while others handle defense. And in the days that follow, while more and more sophisticated cells begin to emerge in the water, joining and collaborating within structured colonies, supervolcanoes erupt, inland seas dry up, open and close, and time keeps passing, with no form of life present on the surface. On November 12th, oxygen, having reached a critical concentration threshold in the oceans, begins to pass in large quantities into the atmosphere. And then the emerged lands literally start to rust in turn. The surface rocks, rich in iron, oxidize, and all the continents take on orange hues. If you had a hypothetical time machine to visit these deserted and rusted landscapes, the first thing you would do after getting out would be to get right back in. Because the concentration of oxygen in the air was more than 10 times lower than what we know today. November 15th. Small, soft marine animals develop muscle cells, a revolutionary innovation that allows them to contract parts of their bodies. And, for the first time, living beings are able to move without relying on the force of the currents. Before the arrival of these organisms, able to move to explore new territories, hunt, or avoid being hunted. All animals fed by filtering nutrients floating in the water. But from now on, it will be necessary to start being clever, because food chains are going to become more complex. A week later, some microorganisms invent a practice that we still often enjoy today, sexuality, which allows them to mix their genetic heritage in a tremendously effective way. When December begins, we see the appearance of specialized cells capable of communicating with each other through electrical impulses. In just a few days on the calendar, these primitive nervous systems form small brains. A week later, the first photosensitive organisms experience day and night. Unable to distinguish shapes, their primitive vision only allows them to detect changes in brightness. It will take several more days before real eyes gaze upon the Earth. Oxygen levels in the air continue to rise slowly, and over the next 10 days, many ecosystems are born and die. Peaks are sandblasted by the winds, mountain ranges rise, others disappear under the relentless force of time and erosion. Rivers carve and shape the landscape until December 12th, when the great winter makes a dramatic return. In the span of just a few minutes on the calendar, the polar ice caps spread to the point of covering almost the entire world. With a layer of ice several kilometers thick in some places, the average global temperature drops to 50 degrees Celsius, and our blue planet turns white once again. Caught in the grip of the ice, this is the cryogenian. This frozen world will remain in place for 2.5 days on the calendar scale until, once again, Earth is saved by volcanoes and the movement of tectonic plates, which constantly rearrange the land masses on the surface, constantly reconfiguring the arrangement of the continents in a giant puzzle game. On December 15th, although temperatures have become milder again, the amount of oxygen in the air is now close to 20%, and the ozone layer, the natural shield that protects the Earth from the sun's deadly ultraviolet rays, has finished forming across the entire planet. There is still no living creature evolving in the open air. On the surface of the continents, all forms of life are still confined to the water. 85% of Earth's history is already behind us, and the vast majority of living things are still desperately small, discrete, and soft-bodied. But that is about to change with the beginning of the Cambrian explosion, which starts the next day, in the late afternoon. When the tree of life suddenly bursts into color, in just a few hours, all the body plans that still exist today appear. Take any animal, whether it's an oyster or yourself, and there's a good chance that the origin of its body structure goes back to that December 16th. In the oceans, sponges and corals now coexist with many animals that, in order to survive, have developed protective plates, shells, or exoskeletons. A variety of new designs are tried out to move quickly, to escape or to hunt, to defend themselves or to camouflage. And advanced sensory organs appear, as well as sophisticated eyes and antennae. In fact, the variety of creatures inhabiting our planet becomes so great that biologists can write entire books about each of the hours of the coming days on the calendar. So telling you this story leaves many other stories aside. As early as the next day, the 4 pairs of jointed legs belonging to arthropods, the ancestors of insects, arachnids, and crustaceans, dominate the oceans. Their numbers, as well as their diversity, will quickly make them the undisputed masters of the animal kingdom. In fact, they are still its quiet rulers today. Just think that today, 80% of recorded species are arthropods. At midday, a giant appears in the seas. His name is Anomalocaris, and he barely reaches 30 centimeters, so much so that if you were to walk along the shores, still lifeless at that time, you would have literally been the largest creature on the entire planet. On the morning of December 18th, fish with a cartilaginous backbone appear. Some of these early vertebrates will, in the following hours, develop a hinged jaw that allows them to bite and crush. It has now been nearly 4 months since life appeared, and on dry land, as far as the eye can see, there is still no moss, no plants, no sign of life in the open air. On all continents, there are only deserts of rock, sand, or ice stretching for thousands of kilometers across the surface, the entire planet. In these landscapes, only the rustling of the wind and a few rare occasional showers break the mineral silence in the middle of the morning. The following day, the northern hemisphere is covered by a vast and unique ocean, while in the south, a supercontinent surrounds an inland sea with an average temperature of 45 degrees. A few mosses and algae timidly venture onto the shores and gradually make their way up along the waterways, centimeter by centimeter. These plants, lacking real roots, and which are the first plants and algae to dare to venture out of the water, begin to transform the nature of the soil. By attacking the minerals, they will take 2 days to conquer the surface of all the continents. 6 hours later, the formation of the large ice caps at the South Pole will lower the global level of all the planet's oceans by about 100 meters. It's a kind of reverse flood. Almost all coral reefs and their associated ecosystems will disappear. On a global scale, only a third of species will survive a crisis. Like so many others, life will recover in just a few hours on the calendar by the end of the day. In the seas, there are Urtoceres, massive cephalopod mollusks nearly 10 meters long, as well as Eurypterids. A Silurian sea scorpion, a skilled hunter, can reach up to 2 meters long, and its sharp jointed pincers terrorize the tropics. Then, around 9 p.m. on the shores, small crustaceans venture into the mud. They are the very first animals on dry land. The next morning, insects and small plants can be found all the way to the heart of the continents, and it's no longer a time of ice at all. All the ice caps have melted, and the sea level has risen by nearly 300 meters. The first amphibians timidly set foot on the shores of the universal ocean Panthalassa. Able to inhale air with full lungs, they are the first terrestrial vertebrates. Minutes pass and they adapt. Solid bones develop in their fins. Soon, they will have permanently left the sea to live mainly in the atmosphere. And now the land plants, which until now were small and modest in size, begin to grow larger. In the first forests of horsetails and tree ferns, we find plants several meters tall. On the 21st at the beginning of the day, some plants develop a small thing seemingly insignificant, but which will change the landscapes of the entire world: the seed. With the development of these survival capsules containing food reserves for the plant embryo and able to remain dormant for years, waiting for ideal conditions before starting to germinate, the first seed plants will spread and thrive in harsh and hostile climates where ferns cannot survive. As the day comes to an end, plants, with their strong root systems, have completely colonized the land, and through their effect on erosion, they now alter and shape the climate. And it is in this world, almost entirely green on the surface, that some insects begin to fly. They are the very first living beings on Earth to leave the ground and conquer the sky. The next morning, it is hot and humid almost everywhere. A large part of the world is now covered by vast, lush swamp forests, whose plants, when they die, will trap the carbon present in their trunks and roots. After several days of compression on the scale of the calendar, this gives rise to most of the coal deposits that we exploit today. For hours, oxygen levels in the air go through the roof. Insects and arthropods take advantage of this energy-rich air, in which oxygen concentrations are twice as high as they are today, to reach prodigious sizes. On Earth at that time, it was not uncommon to come across dragonflies with a wingspan of 1 meter, scorpions measuring 75 centimeters, as well as centipedes nearly 2 meters long, like Arthropleura, a creeping terror that lives in the undergrowth. Giant forest fires break out regularly, because in this hyper-oxygenated world, everything burns more easily, and when lightning strikes, it is often followed by uncontrollable fires. At midday, we find in the forests giant horsetails and ferns from the Carboniferous period. The first reptiles, with their scaly skin resistant to dehydration and more efficient breathing than amphibians, are built to live in the open air. Thanks to their amniotic egg, which contains everything the embryo needs to grow and protects it. Behind a shell that shields them from external conditions, reptiles can lay eggs anywhere, and by doing so, they quickly colonize all the continents. At the end of the day, some plants invent lignin, a remarkable compound that strengthens their cell walls and gives them the rigidity to reach impressive sizes. And we begin to see forests of giant conifers appearing. The next day, all the land masses on the planet begin to come together and give rise to a single, unique supercontinent. Pangaea, at its center, stretches for thousands of kilometers. A gigantic mountain range, the Hercynian Range, whose peaks rival the highest summits of the Himalayas. Today, the presence of these prominent landforms will radically change the climate. In the late afternoon, inland to the south of the Hercynian Range, it is so hot and dry that there are only vast desert regions stretching for thousands of kilometers, while the temperate and humid forests have been pushed to the edges of the planet, near the polar circle. On December 24th in the early afternoon, volcanic eruptions of phenomenal magnitude begin in the region that will later become Siberia. Streams of lava continuously break through the Earth's crust, eventually covering an area comparable in size to Europe with nearly 2 kilometers of lava. Loaded with dust and suspended ash, the sky darkens over the entire planet, while the sulfur dioxide spewed by the volcanoes dissolves in the rainwater, and the clouds weep drops of sulfuric acid depleted in oxygen. Marine environments are suffocated by algae. Meanwhile, carbon dioxide, 2 levels that go through the roof, raise the average surface temperature of the planet up to 40 degrees, and the whole of Pangaea turns into a vast, dry and scorching continent. When the most violent biological crisis the Earth has ever known comes to an end, 70% of the species living on land and 95% of those in the oceans have been wiped out. The colossal eruptions lasted about 20 minutes on the calendar scale, but life as a whole will take half a day to rebuild complex ecosystems, and nearly 3 days to regain a biodiversity comparable to what existed before this brutal mass extinction. It's Christmas Day, when the very first dinosaurs appear, and their lineage will soon dominate the world. They are closely followed by mammals, which at that time are small, nocturnal, and discreet animals, feeding mainly on insects. The peaks of the Hercynian Range begin to lose their splendor in the days that follow. Time and erosion will eventually take their toll. From these aging peaks that inexorably settle and spread out, their worn and eroded remains still exist today. They are called the Massif Central, the Vosges, the Appalachians, or the Ural Mountains. Another day has just passed, nearly 40 million years in reality. And in the early evening of this December 26th, all the land masses on the planet begin to break apart, according to the lines of strength and weakness in the Earth's crust. Eventually, these fractures will create the continents we know today, each one standing alone. For its part, India begins to move northward. It will take 3 days to cross the ocean before crashing into Eurasia. On December 27th, the arid deserts of the late Triassic have been replaced by lush tropical forests. We have entered Jurassic World. Much of the land that will later become Western Europe is now a vast chain of islands surrounded by a shallow tropical sea rich in coral reefs. You probably wouldn't have liked swimming in the warm waters of these idyllic postcard landscapes, because beneath the surface, fast predators like ichthyosaurs or plesiosaurs roam, with enormous bodies reaching up to 10 meters long. As for the skies, they are the territory of pterosaurs, flying reptiles. On the afternoon of December 27th, they will be joined by small feathered dinosaurs capable of gliding. Just a few hours later, they are already flying. This is the birth of the very first birds. In these epic Jurassic landscapes, mammals now occupy all the ecological niches, rarely exceeding 10 centimeters in size. Most of them live in trees or in holes. For them, staying small and keeping a low profile is a good option. Because the kings of the jungle, the dinosaurs, have started a race for gigantism at the beginning of the evening. Around 7 p.m. you can find stegosaurs, allosaurs, and around 11 p.m. the vast conifer forests are roamed by the largest animals that have ever walked on land, the sauropods, whose mass can reach up to 20 times that of an elephant. The following day, the dinosaurs continue to reign supreme. The great inland sea of North America has become the hunting ground of the Mesosaurus, giant marine reptiles related to lizards and snakes. On land, in the forests, there are now touches of color where there used to be an almost uniform green, because on some trees there are now seeds with flesh around them. And the first flowering plants are appearing, closely followed by the first pollinating insects, such as bees and butterflies. The next day, in the late afternoon, one of the hottest periods in the history of our planet begins. All the ice, from the poles to the tops of the mountains, has melted, and a third of the surface of the continents, which just a few hours ago was exposed to the air, is now submerged. In the tropical latitudes, the average water temperature is around 36 degrees, and there are dense forests and tides reaching all the way to the polar regions. At the North Pole, in the middle of summer, it's nearly 20 degrees Celsius. In the lush forests that cover almost the entire planet, conifers, ferns, and mosses intermingle with a newcomer, the leafy tree. This world teeming with lush life will last for another half day on the calendar scale until the early morning of December 30th. At 6:30 sharp, the party comes to an abrupt end. When an asteroid about 10 kilometers in diameter crashes into our planet at around 65,000 km, it leaves behind a crater 180 kilometers wide, and the world is devastated. The dust, thrown into the atmosphere by the force of the impact, then turns day into night in most regions of the world. On the scale of the calendar, this sky veiled with ashes will clear up in a tenth of a second. For 75% of the species living on our planet at that time, their story ends there. For the non-avian dinosaurs, it's the end of an unparalleled reign that lasted 4.5 days on the scale of our calendar. A few hours later, the vegetation started growing back stronger than ever, and in the large temperate deciduous forests. To save their energy, deciduous trees learn to shed their leaves, abandoning their cover for the winter. Without meaning to, they invent the colors of autumn. It's nearly 10 o'clock in the morning when enormous birds, unable to fly and reaching up to 3 meters tall and weighing over 200 kilograms, appear in South America. In the tropical forests of this region of the world, there are giant freshwater turtles capable of eating crocodiles and snakes weighing 2 tons and stretching over 13 meters, the titanoboas. Within a few hours, these species will disappear, and once again, ice caps will cover the land, storing water in the form of ice. They will disappear, drying up the inland seas of America, North Africa, and elsewhere. It's barely 1 p.m. when the mercury starts to soar. The average global temperature will rise by 8 degrees in 45 seconds. At 5 p.m. bats, the first flying mammals with their oversized hands, take to the skies. An hour later, in the vast plains of Central Asia, Andrewsarchus appears, a kind of hyena on steroids. Standing on its hooves, it measures 1.8 meters at the shoulder and weighs 800 kilos on land. The ancestors of cetaceans begin to return to the water. And to be able to breathe better, their nostrils will migrate to the top of their heads. By 10 p.m., they are found entirely underwater. Some, like Basilosaurus, are fearsome predators and measure nearly 20 meters long, weighing 60 tons. At 11 p.m., a species of giant mammal appears in the tropical forests of Central Asia. As tall as a 4-story building, it will drag its massive body across the surface of the globe. And here we are, at the last day of the year. The arrangement of the continents now looks more or less like what we know today. Around 10 a.m., Megalodon appears in the oceans, a species of shark that could be up to 3 times larger than the great white, and it will disappear in the blink of an eye. The ancestors of all the great apes, including us, arrive shortly after 2 p.m., with their grasping hands and their eyes positioned at the front of their heads, giving them stereoscopic vision that allows them to judge distances. And their brains, becoming more and more developed, these primates will go on to colonize a wide variety of forest environments. At 7:30 post-meridian, we begin to encounter the very first hominids and bipeds, capable of standing on their 2 hind legs. Their hands are free to manipulate tools. 3/4 of an hour later, at 8:15 post-meridian, the Strait of Gibraltar closes due to the movement of tectonic plates. Deprived of water from the Atlantic Ocean, the Mediterranean Sea will almost completely evaporate in just a few seconds on the calendar, leaving behind a salt desert located below sea level and, in some places, as deep as 2,500 meters. This impressive dried-up basin will remain in place for about half an hour before violent earthquakes reopen the strait. And a monstrous flow of water, estimated to be 1,000 times that of the Amazon, will come to fill the reborn Mediterranean in a fraction of a second. When this deluge of water from the Atlantic Ocean is over, the global level of all the oceans on the planet has dropped by nearly 6 meters. A quarter of an hour later, at 9 p.m., the Australopithecus appear, and, in the process, many other species of the Homo genus emerge. At 8:40 p.m., we find Homo habilis. At 8:30 p.m., Homo rudolfensis. At 8:20 p.m., Homo ergaster, who is the first to shape tools from stone. Half an hour later, Homo erectus makes his appearance. He is the first hominid to cook food. At 11:44 p.m., we find Neanderthal men and women. They master and preserve fire, bury their dead, and wear jewelry. And when, finally, Homo sapiens appears on the world stage, the clock shows 11:48 p.m. Our species is then present only in Africa. 10 minutes later, we will find our traces on all continents except America and Antarctica. At 11:58 p.m., the first sculptures and paintings are created. At that time, we are only a few 100,000 individuals on the entire planet, but well organized. Shaped stones and mastering fire. We already have a considerable influence, and in the wake of our migrations, 80% of other land species weighing more than a ton will disappear. In Australia, 15 out of 16 members of the megafauna become extinct within 30 seconds after the arrival of the first humans on the continent. Thanks to language, our ideas and innovations can survive the death of individuals by passing from mind to mind. This allows us not to start from scratch, it spreads. Objects like gestures become more refined and accumulate. And in just a few thousand generations, we started making increasingly complex tools, working with bones, making blades and harpoons. It is 11:58 post-meridian, and 30 seconds have passed when we cross the Bering Strait and begin to populate the Americas. It is 48 seconds past when we paint on the walls of the Chauvet Cave. Stories, those of the animals we encounter and hunt. It is 50 seconds past when the Neanderthal man, whom we met and lived alongside for nearly 40 seconds, disappears. And it's somewhere around there, at 11:59 post-meridian. By hanging around with wolves, we eventually tamed them and turned them into dogs. At 11:59, post-meridian 15 seconds past, we invent pottery. And by constantly fleeing snowfalls or drought, by following reindeer, salmon, rivers, the migration of aurochs or horses, At 11:59 post-meridian and 30 seconds, some of us quietly settled in the alluvial meadows. In temperate regions, where agriculture is invented by planting seeds and shifting from wandering hunter-gatherers to farmers, we force ourselves to stay in the same place and build the first villages. 5 seconds later, the Earth as a whole is home to about 5 million people, which is roughly the same population as New Zealand today. And over the next 10 seconds, we learn to cultivate wheat and millet, rice, banana and taro, potatoes, corn, squash and beans. And while we domesticate and transform plants, we do the same with animals. Goats, sheep, oxen and zebu, pigs, chickens and cats are in turn tamed. It is 11:59 post-meridian, 45 seconds past when horses are tamed for the first time, and 47 seconds past when we begin to smelt metals. And in the process, we develop writing and emerge from prehistory. Then begin the last 13 seconds of the calendar, and these include everything we call history, recorded in stone, on clay, or on paper. Ideas, like knowledge, can now be stored somewhere other than in people's heads, and so they accumulate and spread quickly beyond their culture of origin. The second hand hasn't even had time to tick off another second when, right after its arrival, a technique appears that allows harvests to be counted. Dictating laws is like telling stories. The first great civilizations are born in Mesopotamia, in the Indus Valley, and in Egypt. 2 seconds later, the Great Pyramids are built, and in the space of 3 ticks of the second hand, bronze metallurgy is mastered, then iron. Alphabets appear and El builds cities such as Athens or Rome. On a global scale, we have just surpassed 100 million people, the population of present-day Egypt. It is 11:59 post-meridian and 55 seconds have passed. When Christianity appears, the world then has about 170 million inhabitants, nearly a quarter of whom live in the Roman Empire, which is then at its peak. A second later, they collapse. Europe enters the Middle Ages, and during the next second, other empires are born and die throughout the world. In Central America, the Maya Empire rises and then falls. At 11:59 and 57 seconds, the Vikings set foot in North America, passing through Greenland. The world population is now 250 million people across the entire planet, which is a little less than the current population of the Indonesian archipelago. The 100 Years' War begins and ends in a quarter of a second. Then Constantinople falls. The Ming imperial dynasty rules over China for a brief second and then disappears. While the printing press begins to spread knowledge on a large scale, and Christopher Columbus rediscovers America, we enter the last second of the calendar, which contains the entire modern era, the great discoveries, political, scientific, and industrial revolutions, the steam engine, railways, factories, electricity, the 2 world wars, and the invention of a staggering number of objects, for the possession of which, just a second ago, more than one king would have raised an army. And here we are, we've reached the present. Ding dong, it's midnight, it's today. Let's pause for a second on this idea. All our history, everything that has been said, written, read, sculpted, painted, or invented, fits into the last little quarter of an hour of the last hour of the last day of this cosmic calendar, in which the span of a long human life is about the length of a blink of an eye. Your eyelid comes down, and there you go. 45 years have passed, your eyelid rises again right after, and it's already over. Whether it's around a fire, a book, a telescope, a microscope, or the internet, humans have always been driven by the desire to understand the world. By looking into the laws of nature and studying the composition of fossils and rocks, some members of our species have allowed us to trace the grand history of the cosmos, of life, and of our origins. And by bringing back to life the turbulent stories of these now vanished worlds, they discovered that we are the result of a long, unbroken line of life whose story began to be written on Earth when the universe was already 2/3 of its current age. Armed with its knowledge and inventions, our species has acquired immense powers. By burning vast amounts of fossil fuels that nature took millions of years to form, It even managed, without meaning to raise the average global temperature by nearly 2 degrees in the space of a second. Such a short period of time that the only events whose consequences can rival the effects of our modernity are major volcanic eruptions or large-scale asteroid impacts. Yet, despite our incredible knowledge, we are unable to predict our own behavior and therefore what the near future holds for us. No one is able to say, but whatever the answer, one thing is certain: the history of the Earth will continue, and our knowledge of the laws of nature allows us to predict what awaits it over very long periods of time. So here is what we know about it. In just 4 minutes on the calendar, the sky as seen from our planet will look nothing like the one we know today. Because due to their movements within our galaxy, the stars will eventually transform the night sky, drawing hundreds of new constellations. In 40 minutes without maintenance, even the most imposing stone buildings constructed today will have disappeared, after enduring the ravages of time, being sandblasted by rain and wind. And in the days to come, the great waltz of the continents will continue. The East African rift will open up, giving birth to a new sea. North America would partially tear apart, and Australia would bottle up Indonesia, then Asia, while the African continent will close off the Mediterranean Sea before colliding with Europe. It is January 7th when all the continents on the planet have finally come together to form the new Pangaea. Our solar system will then have completed its cycle, a complete revolution around the center of the Milky Way, starting from its current position, and then another revolution around the galactic center later, or a calendar week if you prefer. It will have become impossible to witness a total eclipse of our star, because the Moon, which has been moving away from our planet since its formation, at a rate of about 3.7 centimeters per year, will then have an apparent size too small to occasionally completely cover the Sun. A week later, on January 21, our star, which has been continuously gaining in brightness since its birth, will have already become so bright in the sky that for living beings, overall, things are going to start getting seriously complicated. Because due to its increasing intensity, the erosion of surface rocks will trap the carbon dioxide from the air in the ground. At the same time, the plate tectonics of our aging planet will slow down dramatically and volcanic activity will almost completely stop. So without volcanoes to inject carbon dioxide back into the atmosphere, carbon dioxide 2 concentrations will drop drastically. Until, for almost all plants, carrying out photosynthesis becomes impossible in the following days. With the continuous depletion of carbon dioxide, 2 in the atmosphere, plants gradually disappear, and with them, the animals, who all depend on them indirectly to survive. It's only February. Once the plants have disappeared, the concentrations of oxygen present in the atmosphere collapse, and with them, the ozone layer vanishes, causing the extinction of the last complex life forms on the surface. At the same time, the brightness of the Sun continues to increase, and over the next 2 weeks, it reaches and then exceeds a level of 10%. Today, the average surface temperature is now 50 degrees C, and the oceans are beginning to evaporate, gradually turning our world into a real sauna. Few single-celled organisms can withstand this hell. At the beginning of March, the Earth's core cooled and solidified. The cessation of its movement marks the end of the magnetic field that serves as our protective shield. And the hypothetical remaining forms of life are subjected to the deadly bombardment of high-energy particles coming from our Sun. By mid-March, our blue planet is now blue in name only. The increasing intensity of the Sun has raised the surface temperature of the globe to nearly 150 degrees C. Except perhaps for a few extremophiles relegated to very high-altitude lakes or underground caverns, nothing on Earth can survive inexorably. Life is dying out. A month later, no complex species remain to admire the changing skies, as the Andromeda Galaxy, already clearly visible to the naked eye for several weeks, begins to merge with the Milky Way. Over the following months, the 2 galaxies mix together and, by disturbing the clouds of gas and dust that compose them, trigger the birth of hundreds of millions of new stars, while together forming a giant galaxy that has been named Milky. and it is under a night sky bathed in immense light that the death of the sun begins. Mime. And after exhausting its hydrogen reserves in its core, our star leaves its main sequence and begins to transform into a red giant. 6 weeks later, the sun has become 2,700 times brighter than it is today. And as it expands, multiplying its radius by 250, it has vaporized Mercury and Venus. And its bursts of fury come to lick the surface of our planet, which is reduced to ashes by the very one that allowed it to be born. So, the matter that makes up everything around you, including yourself, will one day end up in the outer layers of the sun. In just a few days, this giant sun will deflate and disappear. Then, at the center, in place of the now vanished sun, there remains only a tiny pale white dot, barely visible. A dying star called a white dwarf, where 50% of the sun's mass is compressed into a volume barely larger than the Earth. And around it, a planetary nebula has formed, made up of layers of gas expelled from the sun's outer layers. This remnant of dead stars no longer has any source of energy and is inexorably cooling, and that's all that's left of fire, our sun, which will have existed for a little less than a year on the scale of the calendar. It's mid-July, and for the solar system, the story is over. But a galaxy like the future Milky, whose sky is still filled with billions of stars, contains enough matter to keep igniting new suns. With their share of planets orbiting around them for hundreds, maybe even thousands of years on the cosmic calendar, other stories will continue to unfold elsewhere throughout the entire universe. From a certain point of view, it took 13.8 billion years to make this video. Feel free to share the secrets of the Templar. You will find a link to TPE here.
What do you think was here before?
I say that this world has always existed.
Yeah, it's been here since the dawn of time.
You mean it wasn't daytime before?
It's resting on the backs of 4 elephants, who themselves are standing on a turtle.
You're talking nonsense.
If you ask me, all 3 of us are wrong.
Yeah, I think you're right. I feel like it's even crazier than that.